Hello everyone. I would like to give you a short insight into the role of regulatory T cells during chronic pancreatitis. Chronic pancreatitis is characterized as chronic inflammation of the pancreas. This results into a local damage and loss of exocrine and endocrine pancreatic tissue, and our aim is to investigate the role of suppressive immune response during chronic pancreatitis. Therefore, we use Dirac mice. In these mice, all regulatory T cells can be depleted by injection of diphtheria toxin. In these mice, we introduce the chronic pancreatitis by a repetitive sertraline injection over 4 weeks, and regulatory T cells were depleted by injection of diphtheria toxin. Control mice received PBS instead of diphtheria toxin. This flow cytometry analysis show that we could successfully deplete regulatory T cells over the whole time period. At first, we checked the effector immune response in the spleen. We cannot observe the difference in the Th1 immune response, but we see that we have an increase of GATA3 positive cells, which indicate that we have more Th2 immune cells. These results were confirmed by an increase of IL-4, a typical Th2 cytokine. From the literature, it is known that Th2 immune cells induce M2 macrophages. Therefore, we stained M2 macrophages in the pancreas as CD206 positive and observed an increase. In addition, we checked the gene expression of MRC1 in the pancreas, and we could see that the depletion of regulatory T cells increased these gene expression too. TGF-beta and IL-10 are both typical M2 cytokines, and these gene expression also increased after depletion of regulatory T cells. It was described that M2 macrophages can activate pancreatic stellate cells, and pancreatic stellate cells express the protein alpha SMA. Therefore, we checked the alpha SMA expression in the pancreas and observed an increase after depletion of regulatory T cells. This finally resulted into an increased collagen expression and fibrosis. We co-stained collagen in green with M2 macrophages in red and observed an increased expression after depletion of regulatory T cells. A Mason-Goldner staining confirmed these increased fibrotic tissue after depletion of regulatory T cells, and also we checked the gene expression of the fibroblast growth factor, and these also increased. All these results into a pancreatic damage and finally reduce acina area expression and a loss of exocrine function. First, you see here that we have decreased acina area after depletion, and we checked the amylase and trypsinogen gene expression in the pancreas, and both decreased too. In addition, mice without regulatory T cells lose more body weight, and this difference was significant after 40 days in Dirac mice with and without regulatory T cells. In conclusion, we could see that the depletion of regulatory T cells induces strong Th2 immune response, activate M2 macrophages, and over TGF-beta and IL-10 we have an activation of pancreatic stellate cells, and this results into an excessive wound healing and fibrosis, and finally in a loss of pancreatic acina cells. Thank you for your attention.